Hey everyone, welcome back. In this video, we're gonna test and diagnose this Ford Fiesta, which has communication issue. Scan tool cannot communicate with many control units. As you see, OBD2 connector is connected to the car right now, and it's getting the power from the OBD2 connector. And when I try to scan the car, I do have the communication just to a couple of control units, not to all of them. And because communication is limited to many control units, not to all of them, the issue for the no communication could be the CAN bus, because if anything happens to the CAN bus, those control units which are communicating together and to a scan tool through the CAN bus cannot respond any further, and we're not going to have communication anymore. For example, if I show you the auto search right now, you see we have no communication. A scan tool was not able to read the VIN number. On this model of Ford, I'm normally able to detect the car VIN number with the scan tool, but right now scan tool is not capable of doing it. We're going to go for selecting the model. It's Ford right here. Manually select, vehicle select Ford. Let's go for Ford Fiesta, this one. We need to select the engine type as well. Now we are on the system selection. These are all the systems that could be on this car. As you see, we have the ABS, audio control system, we have the body control system, front display, instrument panel, powertrain control module, power steering, restraint control system, and so on. Some of these control units are communicating with the scan tool through the CAN bus. So if CAN bus is down, we're not going to be able to communicate with those control units. But some other control units are not communicating to the scan tool through the high-speed CAN bus. So right now, if I go for system scan, let's see what we're going to get. Scan tool is scanning all systems, and it's actually trying to communicate to see which systems are responding properly. So you see some systems are not responding. You will see the results shortly. So out of all those units, we only have these units communicated properly. So engine is not here, steering system, airbag system, they are not here, because those systems are communicating to each other and to a scan tool through the high-speed CAN bus. And right now that we cannot detect those systems, it's clearly saying that there's something wrong on the high-speed CAN bus. That's why we have no communication issue. Just to make sure that scan tool is establishing the connection properly, I'm going to go for the BCM. We are connected, live data, all yes. As you see, scan tool is communicating with BCM right now, so there is nothing wrong at this stage with the scan tool. The other control units are not detected. We need to go for the CAN bus diagnostic step by step. So I'm going to show you how to find the CAN bus. You can find the CAN bus on different locations on the car. We go for the OBD2 connector today. I'm going to show you how to read the voltage and waveform of the CAN bus to see what we can do to fix this issue. We have many videos on the channel for CAN bus diagnostic, but if you're interested to learn more, you can find our online course for CAN bus on our website. The link to that online course is in the video description and the first comment down below. But before going any further, if you guys haven't subscribed to the channel yet, please don't forget to subscribe. And as I mentioned earlier, if you're interested to learn more, you can find the link to our diagnostic courses in the video description and the first comment down below. Now let's start. Here's the OBD2 connector. You know that we have two pins on the OBD2 connector, pin number 6 and 14 for CAN bus high and low. You can actually reach to the CAN bus high and low from here and perform the diagnostic. So what I will do, I'm going to back prop the CAN bus high and low. So we have the test props inserted. We go first for checking the voltage on the CAN bus high and low, and if we cannot find the issue, we're going to read the waveform as well. For performing this diagnostic today, I'm going to use this device from Fnirsi, which is basically a multimeter, oscilloscope, and signal generator. We're going to use the multimeter function right now to read the voltage, and if we need, we're going to go for reading the waveform using this device as well. If you're interested to learn more about this device, you can find the link in the video description. Ignition switch is on right now. I'll select the multimeter function, red probe over here, and black one on a good ground. So the voltage that we are getting right now is 2.7. This is clearly CAN bus high. CAN bus high voltage oscillates between 2.5 to 3.5 when we are reading it with oscilloscope. But when you read it with multimeter, you're gonna get something close to 2.6, 2.7. So this one is okay right now. If there is any short circuit on the CAN bus, you're gonna get 0 volts. But this one is showing that the voltage on the CAN bus high is okay. Now we proceed for the voltage on the CAN bus low, which is basically the other test probe that I have in here, and ground. As you see, the voltage right now is 2.2. This is what we are expecting on the CAN bus low. CAN bus voltage oscillates between 2.5 to 1.5 when CAN bus is operating. So when we are checking with the multimeter, normally we're going to get a voltage range between 2.2, 2.3 sometimes. This one shows that the voltage is okay. At least there is no short circuit on the CAN bus. So right now that we check the voltage and everything is normal, the next step could be checking the waveform on the CAN bus, because sometimes voltage is not going to show us everything, but the waveform is a great way to diagnose the CAN bus. For that, we're going to use the oscilloscope function of this device, which is here. I'm going to change the probe. This device provides one channel on the oscilloscope for us. And here's the probe. I'm going to put this one on the CAN bus that we're going to read. And this one should be connected to a good ground. Right now we are getting the waveform. As you see, waveform is too short. You can press the auto button in here. If you select this one, oscilloscope is going to adjust the waveform for us automatically. You can do it manually from here as well. This is for voltage setting. This is for the time setting. For example, right now, if I want to make the waveform taller, I can do it from here. If I want to see more number of waveforms or less number of waveforms, I can adjust it from here as well. You can simply press auto and wait for the oscilloscope to adjust it for you. Over here, you can select the minimum or maximum voltage that you need. For example, these two. And oscilloscope is going to show you the voltage value in here. Apparently, we are getting the waveform. But if I pause it, first of all, we see that the waveform that we are getting is on the CAN bus low. That's why the voltage is dropping. The voltage that oscilloscope is showing us right now, the max and minimum voltage is 2.47 at the maximum and 1.3 at minimum. You can select the cursor over here as well. For example, this one, and select it yourself manually. You can move these ones up and down, just like this. And this one over here, then you can read the Y1 and Y2, 2.43, and Y2 is 1.38, these two that I selected. The waveform that I'm getting is not too bad. The waveform on the CAN bus low is good. We are getting the waveform, CAN bus low is working. Let's switch the oscilloscope probe from the CAN bus low to CAN bus high, and then we're going to run the waveform to see if we are getting the waveform on the CAN bus high as well. And now let's go for running the waveform. You see the waveform now is changed right here. If we pause the waveform, we can actually read the waveform right now. Minimum and maximum voltage are shown in here, but we have a little voltage surge at the end when a message is completed. You can go for the cursor, move this cursor to this point, this one to this point. As you see, we are getting 3.5 at Y1, which is exactly what we want, and Y2 is showing us 2.31, which is okay as well, because the voltage normally oscillates between 2.5 to 3.5. A little higher or lower is acceptable, but if it is too off, it could be because of some issue on the CAN bus. But right now we are getting normal waveform, we are getting normal voltage. What could be the cause of this no communication? CAN bus is working properly apparently in here, but still our scan tool is not communicating properly. When I was trying to insert the back probe, you notice that I inserted the back probe from the back of the connector because I didn't want to damage the pins. Even if sometimes if I don't have access to the back of the connector, if I try to test any pins, I'm going to use the test probes, which are really thin. They're not going to damage the connectors, or they're not going to damage the pins. But when I was looking at the connector, there is something really interesting. If I hold it like this, you might see pin number 6 and 14, which are right here. If you see, there's a clear deformation on the connector. Maybe here is easier to see. You see the other pins are completely square, but this one is rounded, this one and the other one. Apparently someone has been trying to check something on this connector, and most likely they pushed the multimeter probes into the pins, widening the female pins. So clearly this could be the no communication issue, because CAN bus is working right now, but the connection on the pins is not correct. So I'm going to go ahead to remove these pins from the OBD2 connector, fix them, put them back in the connector, and we will try it again. This one is widened a lot more. I fixed the pins, inserted the pins back into the OBD2 connector, and connected the VCI. Now let's go for checking the scan tools. Let's see if we can get any communication right now. Let's go for the VIN search. VIN number is detected right now, and we are getting communication. Auto search this time. Yes, we have all the information. Let's go for the smart scan. And now, as you see, ABS is detected right now. We have PCM as well. So we're gonna clear the DTCs. We erased the fault code. As you see, we are still having good communication with all units on the CAN bus, including the PCM, airbag, and ABS. And the problem on this car was only bad connection on the OBD2 connector. Sometimes diagnostic on the CAN bus could be very tricky. We have to just check the wiring step by step, as I explained on previous videos. But sometimes the diagnostic is not that much complicated. If you notice any minor details. Before recording this video, when I checked this car, at the very first glance, I noticed the deformation on the OBD2 connector, and I noticed the issue could be from the pins. But I wanted to explain everything to you guys step by step. When we have no communication and the voltage is normal and the waveform is normal, the problem could be something like this, that the scan tool is not communicating because maybe the pins on the OBD2 connector for the CAN bus high and low are damaged, like this case. So the only thing you need is to carefully remove the pins from the OBD2 connector, inspect them, do any adjustment or cleaning if required, put them back in, and check the car again. Any device I used in this video, including the Fnirsi 3-in-1 device or the scan tool that I tried today, you can find a link for those ones in the video description. And if you're interested to learn more, you can find the link to our diagnostic courses in the video description and the first comment down below. Thank you very much, guys, for watching. I hope you enjoyed the video. See you guys in the next video.